Hi everyone, I'm Mukit and this is Lec-Recall. I built it for Melbourne Hack 2025 to tackle a simple question. How can AI accelerate learning for high school and university students? First, a quick look at today's AI in education landscape. Today's AI in education tools mostly fit three buckets. First, AI study companions, the always-on tutor that explains concepts, answers questions, and teaches step by step, similar to how students already use ChatGPT for study and learn tasks. Secondly, AI-generated quizzes and flashcards, tools that turn notes into bite-sized cards, auto-adjust difficulty, and use spaced repetition. Think products like Alice. And lastly, AI graders, which are teacher-directed assistants that score against rubrics, give feedback, and adapt across curricula and formats, tools like Edexia. So what's still missing in live classrooms? Two big gaps remain in live classrooms. Firstly, stagnant classroom infrastructure. 15 to 20 years with few changes beyond projectors and basic digitization, and very little true AI integration. And secondly, attention deficits in large classrooms. We've all been in those big classrooms which correlate with shorter attention spans, more mind wandering, and lower retention because instruction is mostly one way, interaction is limited, noise is higher, and accountability drops significantly. Here's how I'm addressing those gaps. Lec-Recall is classroom software that synchronously generates interactive activities and receives live feedback with minimal lecture intervention, turning a one-way lecture into a two-way learning session. Under the hood, Lec-Recall transcribes lectures in real time, detects questions, and auto-builds quizzes on the fly to drive active recall and engagement. While students interact, lecturers get live confusion signals to see where the room is lost or confident. At the end, students receive personalized review summaries, and the lecturer sees per question dashboard highlighting gaps. In short, the three pillar features are live quiz generation, live feedback, and end of lecture analytics. Now let me show what it actually does. Landing page, the user has to choose a role. So on the left side, we're going to put the lecturer, and on the right side, we're going to put a student. Let's quickly enter the details. John, let's give the session a name, and let's set the quiz timer to 30. As you can see, we get a 6-digit join code, which students need to use to join the session. Now let's start the class. Hi, everyone. Today, we are going to be talking about data structures and algorithms. As you can see, whatever I say gets transcribed under the transcription box. Now let's try asking a question. For instance, what is a data structure? As you can see, the question gets detected and a quiz gets generated in real time. Now on the student side, let's give the answer to this question. Immediately, it shows that the student got the right answer. Now let's try another question where the student will give a wrong answer. For instance, let's ask, what is the capital of France? Let's put on Leon to demonstrate a wrong answer. As you can see, it immediately shows that the student got the answer wrong. Let's also try asking a question which is more generic in nature and not related to a quiz. For instance, let's ask, how are you all doing today? As you can see, it understands that this is not a relevant academic question and a quiz is not created. Now, let's say that during the lecture, students are feeling confused. They can indicate this by clicking on one of the confused buttons, and the lecturer immediately can see that a student is confused. Now let's end the session. Once we end the session, on the lecturer side, we get session analytics per question showing how many students answered a question and what was the accuracy in terms of the answers. They also get like a nudge on which questions or topics to review for the next class. On the student side, they also see the answers they gave to each question as well as the correct answers. On top of that, they also get a lecture summary based on the transcript of the lecture. Landing page, tech-wise, the front end is React 19 with a Socket IO client and modern CSS. The backend uses Node, Express, and a Socket IO server. We store structured data in SQLite, run Google Gemini AI for content processing, and use DeepGram for real-time transcription. Everything syncs via WebSockets for low latency interactivity. We built with the classroom in mind. Dark mode for comfort, WCAG 2.1 AA accessibility, including screen reader support, and responsive layouts for phone, tablet, and desktop. The goal is zero learning curve for both students and instructors. This is also cheap to run. Speech to text is about $0.26 for a 60-minute lecture. AI processing with the Gemini 2.5 flashlight adds pennies, roughly $0.04 for a typical run. All in, we expect well under $1 per class before general hosting, making it feasible for large courses and budgets. To support production scale for data, we can use a managed relational database with backups, a fast in-memory cache for live features like quizzes and the confusion meter, durable cloud storage for audio and transcripts, and an analytics store for trends. For network, a global CDN keeps the app snappy, and a managed load balancer smooths traffic. For hardware, lecturers can use a laptop mic or plug into the room's mic feed. Students join from any browser on any device. This setup is ready for production scale classrooms. Lectures still behave like broadcasts. Lec-Recall turns them into conversations, live quizzes, real-time confusion signals, and end-of-class analytics that make attention visible and retention measurable. It's intentionally frictionless. A six-character join code, clean responsive UI, dark mode, and accessibility baked in. Web first means no installs and it runs wherever students already are. In practice, the teacher gets a live engagement view during class and focus reports after. Students leave with instant practice, feedback, AI summaries, and personal analytics. Most importantly, it acts during the lecture, detecting questions and generating quizzes as the lecturer speaks, with a roadmap to adaptive difficulty in collaborative annotations. You can find our project on DevPost and the code on GitHub. Thank you.